Hello, everyone. Welcome back to yet another episode from the FM Times podcast. And firstly, before I proceed with the next episode, I would just like to thank you guys for the love that you've offered for the earlier two podcasts. So it clearly, it's kind of a living proof that the content that we are taking out and the way we have taken it out over the last couple of episodes has resonated with you. So we promise to take out the content in a similar manner as we move forward. And in this episode, what we're doing essentially is taking normally when you look at a lot of the podcasts that comes out from FM Times podcast, you look at it's like a strategic in nature, largely meant for C-suite or senior leadership, and we thought that we are going to be mixing in it a bit of content to allow facility managers or maybe mid-level managers to be able to have some content for them so that it helps them in their journey. And one of the conversations I've always had when I work with a lot of facility management companies, especially managers, engineering managers, they've always thought, they've got into this entire sort of a mix thought where they think that the impact of the small proactive measures that they take sometimes is very difficult to demonstrate it to the customers, to stakeholders, or probably even to their senior leadership and saying, okay, hey, we have done this small change in the AHU, in the chiller, or in the FCU, but it isn't really showing it, up on the overall meter or the measurement. So what we're going to do in this episode, we're going to talk about how you could take a slightly different approach, engineering wise, scientific measurement wise, and then build that so that you have the ability to demonstrate the impact of every proactive measure that you take. Uh, Now, obviously, we have seen that all facilities do not have the best of metering infrastructure. So you're not going to have a lot of downstream metering infrastructure, which would mean that not all assets would be connected to meters, and that's absolutely okay. I mean, I personally don't think that that is the state where we want to be, especially for a lot of brownfield projects where your buildings and the built environment is already there. For new greenfield projects, you're able to kind of do that. So this will essentially come in very helpful for the sites where facilities are managing. They're already in place. The infrastructure is already there. How do you really go ahead and demonstrate the impact on the measures that you take? One of the things that in energy efficiency largely is very important is measurement and verification. There are standard processes, procedures, and standards that have been put into place to be able to demonstrate measured savings or deemed savings, which a lot of us use as a word, but do it scientifically versus doing it very sort of in an ad hoc manner. And way early in my early consulting days, I took out a presentation and a concept where I said that if we could use black box approach or data to drive energy efficiency investments, and I'm sort of going back to that fundamental presentation today, but bringing it more in context of facility management. So here is how I look at this concept: series of small steps that can help you go down that path of demonstrating the impact of every proactive measure that you take, no matter how small it might be. Because at the end of the day, all of those smallest measures that you take are going to create a large impact, something that will eventually be seen at the meter level. So what's the step one if you're doing any project on adding value, which it could be change in maintenance schedule, it could be proper operation procedure, or purely an energy efficiency exercise? Keep it simple, because every saving matters, especially more in the current context of how we are looking at the built environment or facilities in general. Step two, define the localized boundary of the project. So if you're doing something on the AHU, so which AHU are you doing? Which FCU? Which chiller? That is very important to define the localized boundary and not look at it immediately as a part of a very big facility. Just look at it at the localized level. This would be very helpful if you do not have downstream metering, and which is the case with probably 70% of the facilities that we have. I mean, your chillers probably would have energy meters, but not every AHU or FCU certainly will not have the BTU meters and electricity meters in that sense. Step three, the most important of that, which is establishing a baseline. Now, which means you could use two or three methods depending upon what kind of data is available. And in general, these would be available in absence of metered data. One, is use the operational data. What percentage VFD is operating at? Let's say you're trying to do a bit of tweak on an air handling unit, on the fan side of things, or on the pump side of things, or probably in the FCU, and you're saying, okay, for example, what is the current level at which the VFD operates? What is the percentage opening of the valve position? So take down those numbers. You could either get it from the BMS. If not, then you could, for as far as VFD and other points are concerned, you could get it simply from their from the display panel, depending upon the kind of data infrastructure that is available. And then third is you could use measured data, which means you could take the good old power analyzer or a meter and clamp on meters and figure out what's the power consumption that's happening. In case of electrical energy, certainly that's possible. And if you can't measure, you go back to your standard operating procedures or SOP or manuals or commissioning data and say, if the asset was running at 100% capacity, what is the kind of energy it would consume? And then go back, do retrospectively and say, okay, it's probably at 60% and this is what it's expected to consume. So that's still scientific. The idea is the best method definitely is to have the metered data. But we're not living in an ideal world, so we'll have to look at what are the other alternatives that are available, that are scientific in nature, that could hold the engineering principles. So that is something that certainly does. Step 4 is for you to make the impact, make the proactive measure, and repeat the exercise that you did in step 3, which is go back, take the operational data again, take the measurements again, look at the design parameters and say, now this is the level at which the asset is operating. What is going to be the energy consumption that it is expected to consume? And then with that, you have a before and an after. That is something that is scientific, fundamental, and then you establish the difference from all perspectives. So you give yourself multiple references for the savings that you've made, not just one reference. So ideally, if you do not have meter data, use all three if you can. That's probably the best scenario to be in, so that there's very little challenging that can be done on the data that you're using. Step 6 is to amplify. Now, when you do this across 1 AHU, 2 AHU, 3, 4, all of a sudden, you are creating significant impact, which would certainly be visible at the lowest possible available downstream meter that is available on the particular site. So I think that's a good process to be in. It's a good mental framework to get into, because I think at the end of the day, if you have done something, if you've saved something, if you aggregate that, it's ultimately going to show up. But the hope with this particular, if you follow this particular structure or any other mental process or a different process that you might as well have, one thing is definitely going to be there, that you will not have this as a limiting fact. It's really not good to say that, okay, we don't have meters and we don't have enough proof points, and hence probably we would not really be making proactive impact. That's probably not what it should be. That should be the last thing stopping your team from making a proactive impact. So a quick recap on what are the 6 steps. Step 1, which is keep it simple. Step 2, define the localized boundary. Step 3, establish a baseline. Step 4, make the impact. Repeat the steps. Step 5 is establish the difference. What have you saved? And step 6, amplify. Keep on doing it across the site. Add those numbers up, and they're going to become huge. If you or your engineering team at a particular site follows a different process, would love to know more about it. And if this helps you, we would really appreciate if you could drop in your comments on the links or wherever you're consuming this podcast, and let us know what you felt, whether this is helpful. And again, as I said, if there's something that you do differently, we would certainly love to know. Thank you so much for listening to this podcast.